Okay. In terms of what we want to do this afternoon, what we'd love to do for finishing up is as follows. We would love to basically go through and walk you through the experience of creating kind of like a little structure really from start to finish, and really starting to explore what's involved in putting down the walls and doors and the windows and all those things, and kind of getting some control over that so you can start really designing your own structure. And in terms of where we're going to get to today, based on where we were last time, I'm going to give you sort of half of an assignment to work on at the end of the class, where, the whole issue is at the beginning, walls, doors, windows, and things like that, you'll be able to kind of work with and practice on and get started with that. For the due date, we're not going to get far enough today to get completely through the whole thing, so treat that more sort of a practice thing for you to work on. But if you work on some of it tonight in terms of getting some of those basic skills down, it'll be easier to complete the whole thing when you finish tomorrow. Make sense? Yes. Being realistic about where things are going. And what's nice is you guys, I don't know, you're a little ahead of the A group, largely because you have more time to prepare and get things going. It's like somehow, yeah, we're moving a little slower there. But that's okay, because we don't have to go real slow start just from doing all the software install and machines. Okay, let's get going and think about just creating a brand new Revit file. And as you're going to do this, it all starts looking something like this. When you open up Revit and you're ready to start creating something new, you have on the main splash screen a choice of open or new or some of these different things. We're going to open this new, and we're also going to open the architectural template. If you're working on one of the workstations here, one of the workstations where it's already installed, again, you'll say new, and we'll sort of get that same choice. There'll be a couple times as we're working today where things will look a little bit different between 2012 and 2013. But I'll try and steer you through what those things are. For right now, just say new, and then it's an ask which template to use. And in general, you're going to use the one that says architectural template. So let's see if you can get yourself to a brand new blank workspace. And let's see what that looks like. So this is what a blank Revit template looks like just right out of the box. You can find it's pretty boring. There's a couple things that are set up there for you, but it's really just like a blank slate with a blank canvas just waiting for you to do things on top of it. You will see that in the blank template, there's a couple things that are available. There's a couple different levels that have been set up, level 1, level 2. There's also another view called site. There's a couple ceiling plans, and there's some elevations. It's going to talk about where all these things are. The notion of level 1 and level 2, every project has levels, and you sort of like to know where the 0 point is, typically the subfloor or the first level, or it could be some other sort of point right now, but you like to sort of know where level 1 is and what the height, the floor-to-floor height is between the different levels. And if you want to check those things out, the thing to do is go to any of the elevation views. You can't see them in floor plan views, but any of the elevation views will do it. So it doesn't matter, I always go to south for some reason. There's no reason in particular, but if I go to south and I zoom on in a little bit, you'll see I have some levels set up. I have level 1, I have level 2. Level 2 is currently 10 feet above level 1. It's fine enough in terms of what's going on. If I want to go ahead and move that, if I want to have a different floor-to-floor height, because either I have an old house, for example, if I was doing a little kind of a wood frame house from earlier, maybe 20 years ago, I probably would have 8-foot tall ceilings going from level 0 all the way up to level 2. So that'd probably be at 8 feet. Yeah, that's changed very much so in the last couple of years, where now it's quite common to have 10-foot ceilings or even higher in terms of what's going on. But you can go through and figure out what's your level to level kind of distance should be for whatever building you're working on. If we're working on a commercial building, we would probably have, the 8 or 9 feet before we get to the ceiling, and we'll have a couple feet of interstitial space above the ceiling plenum before you get to the next floor level. So that might be 12 or 14 feet, whatever it happens to be altogether. Okay, if you need to add some more levels, we can do that too. This is all currently set up by default just for like 2 levels. If I want to add another level, it's pretty straightforward. What you're going to do is, under either the Architecture tab, if you're working in Revit 2013, or if you're working in Revit 2012, it's just the Home tab. Either one, it's to the same place. Way over on the right-hand side, you'll find the Data tools, and one of the tools that's available is the Level tool. So if you go through and choose that level tool, we're basically ready to start drawing some levels. I can just draw them. I can zoom on out and do it, or I can just sort of do it in a zoomed in version and stretch out the level markers later. I can just start drawing the level. I can tend to like to make the level markers line up on the right-hand side. That kind of locks them together so they move together. When I click there, I now have level 3. What it's going to do is it's going to take the last level name that we created and just increment it. So whatever that last thing is, if you were at level 5, we'll make level 6. I'm just going to keep on adding that up. And that last distance there is 10 feet. If you want to change that, you can in a couple of different ways. We can change that by either just choosing the level marker, and you'll see the distance there is 10 feet. So I can make that 12 feet instead if I want to raise it up. Or if you want to, you can come and click just right in a little piece of text that says 22 and put in the new elevation you want that to be. There's a number of different ways to go ahead and move that stuff around. So just go ahead and create yourself another level. Another thing you can do with levels, though, is, let's say the naming convention for levels is really just up to you, whatever sort of feels right. You know, a two-story house, she may say level 1, level 2. Maybe you call level 3 the roof level. And if you want to do that, that's really simple to do too. If you want that to be roof as opposed to call it level 3, because that'll be more meaningful to you as a name, just click in the level 3. And when you type in roof, hit the enter key, it'll say, hey, you've changed the name of the level. I have the level over here. Would you also like to rename the plan views? So see where it says level 3 over here. Yes, we'll go ahead and change it. So that's called roof also. No will be, you'll call it roof over here, but it'll just still be level 3 over there. I always like to rename things and make them correspond. Otherwise I get very confused. I like to have the roof is level 3 up next. Well, let's take a look at that. If you do not have it on your laptop, chances are, let's see what's going on. Use a project. And then, okay, you're in the same situation someone else had last time. Basically, when you loaded the application, you go to the library files that we code for you. So what we'll do is, I'll send out a message, tonight that actually says where you can download those libraries. For now, just go ahead and say none. It's going to be enough to get us started for what we're doing in class here today and make it in imperial or metric, whatever it is. But we'll need to sort of like put that back in. I'll send you a link where you can download the files, and then in the application you can point to where the files are. Does that make sense? Yes?
How do I change units?
Very good. You should change them to whatever you're comfortable with. So, what you do with that is under the Manage tab, if you like to work in metric units instead, let's go to under Manage. There's a notion under here. Let's see if I can get it to catch up with me. Okay, it's a little hidden in here. Oh, I got to even find it in here because things are so squishy here. Which one are they? There it is, project units. Okay, UN is the shortcut for opening up. That'll let you sort of change all the different units, whether it's the length unit, the slope unit, whatever it is. If you prefer to be working in meters or in millimeters or whatever the scheme is that makes the most sense to you, go ahead and change that. Use the centimeters or fractional meters, or you can choose whatever you want. This is going to work there. The nice thing is, what was it? It's going to sort of maintain things the same size. So even if you do something all in metric and you change it over to US or vice versa, it'll just automatically handle the conversions. As we're going through and typing things, if you know that that distance should be 3 meters and you don't want to do the conversion in your feet, you just type in 3 meters, it'll go through and do the conversions for you like automatically. So it's actually very fluid about that. But yeah, definitely set it up to a unit system that's comfortable to you so you have a good sense and an intuition about what it is. I know it's very confusing to be working in the wrong system or a different system than the one you're used to. Okay, so we got some different levels. Again, what are our levels good for? It's really just a little bit of a framework because we're going through placing walls. We're going to want to be placing walls either level 1 to level 2 or level 2 to roof, or somehow as we're talking about the height of the walls, we don't want to be talking about the height of the walls explicitly. I don't want to say it's an 8-foot wall. I want to understand is it from level 1 to level 2, or it's much better if you can say that it has a relationship to one of the other levels. Either it's shy or above one of the other levels, and kind of hinged off a parameter. It gives you a lot more control, because what happens then is if any of the parameters change, the wall will change with it. So in general, having good levels set up as a starting point is good, but then as we go through and look at things, always hinge things against levels whenever we can, or other parameters. So it's much more powerful. It's all kind of managing what's going on by constraints as opposed to doing it as explicit numbers. And it gives you a lot more power in the long run for redesign. Okay, so you got some levels to work with? You feeling good there? If you got levels, let's go ahead and start creating some walls. And what I'm going to do, I'm going to open up the fun little handout. No, not that one. How about that one? Okay, and again, these are out there for you too, and it's just kind of a loose guideline for what we're doing. We're going to be focusing on really creating the elements of the building envelope today, exterior walls, windows and doors and things like that, as well as things like the roofs and curtain walls, things like that. Realistically, we'll probably get through these items today, not so much through those items. We'll probably pick those guys up tomorrow in terms of what's going on. But as you're doing your design, it's important when I'm talking to architects about doing these things to remember always that as they're first starting to think about modeling things, there's aesthetic requirements that they're trying to meet, there's some functional requirements, things like taking care of the loads or taking care of a thermal barrier between the inside and the outside. Sometimes we go through and choose different wall types based on a construction technique we might be using. There's a number of different reasons we choose different attributes of walls, but there'll be some reason for why you're going through and choosing the wall types. And what we want to do is then model things accurately relative to the way they're going to be constructed. One of the first rules that we're going to continue to try and honor throughout the class is that we never try to model things just to make them look right. We're always going to try and model them as accurately as possible the way they're going to be constructed, because the downstream clients, the people who are going to be estimating using your model or doing construction sequencing or building it out in the field, they're all going to need to have an accurate model to work with. So there's a lot of things we can do to kind of slough over some things and make them look about right. But accuracy is really key. And sometimes you're going to find that it's more work for us to model things accurately than it would be just to draw them. But really, the problems that we solve by modeling accurately here are going to save problems in the field. Because it's much cheaper for us to fix them on the computer than it is the other way around. So that's sort of the overall guiding principle. Yes, always be modeling things relative to the way they're going to be constructed. Okay, as we're working with walls, let's go ahead and switch back over to the floor plan view and just kind of talk about some basic walls and how we do it. The main tools that we're going to work with as we get started are going to show up either on the Architecture tab if you're in Revit 2013, or on the Home tab if you're in Revit Architecture 2012. But on that you'll find walls, doors, windows, roofs, floors, all the biggies. We're going to start with the envelope, but all right up top. So as you go through and, for example, choose the wall tool, let's take a look at what actually comes up. There are a number of different options that'll pop up that are going to help us really decide how to go through and place this wall. There are different drawing methods that are available over here. So we can place walls by drawing individual line segments. We can place walls by sort of drawing a rectangle and having walls around that way. We can either inscribe or circumscribe. We can go ahead and create circles, arcs, lines. There's a number of different things you can do to go through and create different walls and have them follow. But basically, the rhythm is that we're going to go through and create a 2D line, and then based on that line, some 3D walls will show up on the wall. Okay. As we're going through and placing the walls, there's a couple things we need to think about. As we're drawing in 2D, we have to think about what the height of the walls is going to be. There's a couple ways to think about the height. One is if you say that it's going to be an unconnected height, that would say that explicitly it's going to be 20 feet tall, and that's okay if you know that it always is going to be 20 feet tall, but it's actually much stronger to go ahead and instead limit to one of the other constraints, to limit to like level 2 or to roof. The reason being, if level 2 or roof changes, even the wall will change with it. So much better to actually link it to another constraint or another parameter than it is just to put a hard number in there. Hard numbers are rarely the good things because that's encoding sort of one specific decision. It's much better to encode your design intent. If we get your intent, that if something changes that changes the answer relative to your intent, it'll change for you automatically. So I'm going to say, let's change it to level 2 as opposed to 20 feet. That's going to be a better choice for what I'm going to do. We also have the choice over here, as we draw the wall, should we be drawing it so that it is centered on the line that we draw, or should we be choosing the inside or the outside face of it? We'll talk about walls and all the different attributes of them in just a second, but I'll just leave it at wall center line for now. We choose the type of wall, and you'll find there's a lot of different types available here. These are, kind of some good ones to start with. They're certainly not comprehensive, and we're going to talk right away about how we can go ahead and change this to be a more custom set for what you need. But as a starting point, there's some generic ones, but don't have any particular materiality to them. There's some masonry and some brick walls. There's some multi-layer walls in here. We'll start with a simple one as a starting point and go from there. So here's how it basically works. I'm going to choose like the generic 8-inch wall. I'm going to start drawing, and as I draw, I'm going to start drawing some walls out here. You'll see that some little dimensions show up, giving me some sense of the size that I'm drawing. Notice as I get to sort of what I'll call key points, little inference lines kind of show up to kind of give me some sort of sense that I actually have hit kind of an interesting point relative to the other points I've already placed. Now you'll find that as I'm placing walls, I tend to be fairly just free and kind of very quick about placing the walls down there, not paying an awful lot of attention to dimensions as I go. Well, they're about right. But what I want you to start thinking about is that it's very, very easy to change things here. So if, for example, the building wants to get narrower or wants to get bigger, or whatever you want, I can just sort of push and pull on things and very quickly change it around. Deformability is one of the big things that's really nice about working in BIM modeling environments. So it's not critical that you get it down in precisely the right place the very first time. You can sort of push and pull very easily. Now, as you're working, you might be thinking that we're only creating the 2D representation, but you're actually creating the 3D representation too. If you'd like to see the 3D representation, what you'll do is you need to open a 3D window, and you'll notice the default 3D window isn't showing here. So go to the View tab, if you can. So go to View. And then if you do choose View, you'll find something in there that says the 3D view, the default 3D view. Just choose that, and you'll get something that looks like this. So now I have these two views. One's 3D, one's a 4x.
It's like properties. Whenever it's
no worries. That happens every once in a while. It's like it's hidden. It's very easy to kind of hide it by accident. Try this. There's a couple different ways to get it back. One is, if you go to the View tab and go to User Interface, you'll see there's actually the choice of whether the properties window will show. So you can turn it on there. The other way you can do is, you see there's actually a shortcut here, TP for properties. If you click that, it will either show up or go away. But it's real easy to turn this thing off by accident. For example, even like when I have a wall selected, see properties is available right there. If you just hit that by accident, it may keep on appearing or disappearing. So you can bring that back pretty quickly. Yes?
What if you actually get rid of the actual walls?
No worries. You want to get rid of those walls? Well, you can figure this one out. Go ahead, and I got some extra walls. No worries. Exactly. I hear the answer coming up right over there. You just click on the wall, and you can either backspace it or delete it. Either way.
Do you have to get out of them first?
You're just going to be able to select it. So where are you now?
Well, I'm kind of selecting.
Oh, if you want to.
There's so many because.
No, if you want to select them all, if you go and grab the one first, that, and then backspace it. Again.
Yeah.
Oh, I think it's just like 2 steps behind you.
Yeah. Mine's
No worries. You're heading on the right path. We've been doing that. Okay, let me go ahead and tile these windows together just so you can sort of see how these things look in both views. If I want to tile them, what I'll do is say View, and either WT for window tile, or I'll just go ahead and tile them right there. You can actually see, oh, I have several different views right now. I have the 3D view as well as I have the 2D view down here. And the nice thing is, I'm even going to close up that elevation view. They're in the elevation view, but I'm not very concerned about them right now. Make that a little bigger. If I go through, if I choose any of the walls, notice it's highlighted in both the different views, and I can start moving the walls around. And it'll change in both those different views. Yes?
When you're selecting the constraints for the walls,
Yes.
and you're in level 1, you're always going to be drawing on level 1.
Mm-hmm.
If you select like roof, is it going to give you a 20-foot wall, or is it going to give you a wall from level 1 up to the roof?
Actually, it's a very good question. What it is it'll always assume as a starting point that the base is like, for example, if you're on roof and you start drawing walls, it'll assume that the base is going to be roof. Okay, but you can always change it. So we can change the bottom as well as changing the top either as we draw or after the fact. So we'll talk a lot about how we can kind of change those height constraints. So by default, it's going to try and be smart and say, oh, you're on the roof. You must be wanting to draw at that level. But you can always change it after the fact.
Okay.
Okay. So 2 things to think about relative to these walls. Actually, 3 things you want to think about relative to these walls. One is these walls have some sort of thickness and materiality, and we haven't really done a very good job of capturing what that is so far. The other is this whole notion of the height of the walls and what we want to have happen there. So let's go ahead and let's talk about just thickness of the walls, and we'll start talking about just how we sort of create walls and sort of what we like. Here's the deal. If you pull down over here, let me even zoom on in here a little bit to get a sense of what I'm after. And I pull down over here in the little type selector, you'll see there's a bunch of different wall types here. There's a generic 8-inch, generic 6-inch, generic 5-inch, and then some thicker walls that have multiple layers to them. So how it works is if you go through and choose a wall and choose a much thicker wall type, it'll show that to you. Let me even kind of zoom in real close, and I'm going to shade that view just so I can sort of see the red brick, get a better sense of what's going on in here. You'll see it's kind of looking like there's 2 different thicknesses in there. Okay. Let's go down, I'll do that. I'll highlight that same sort of area right here in the floor plan view so you sort of get a sense of really what it's up to. Okay. You can probably see now, let me even zoom in closer, that there are 2 different thicknesses involved. It's kind of the thinner wall and the thicker wall over here. Now, in the level of detail that we're showing right now, it's really not showing us all the different layers, other than the fact that it's a little bit different on thickness, you might not be able to tell what's going on. If you want to start to see really how those walls are made up and really understand the layering, you can do something that's called changing the level of detail. So where that is it's of the different view controls down here at the bottom. It's the very first one on the left. I can change that if I go to either medium or fine, either one of those. It'll actually show us the layers. Sometimes I shade those 2 just so I can sort of see the coloration. So we can start to see that there's a couple of different wall types here. There's one wall over here which seems to be some sort of uniform material all the way through for 8 inches. There's some other material over here where there's some sort of core, there's some other layers, there's a sheeting layer, there's a brick layer, the moving layers. Now, as you're working, okay, there is a notion of every wall has a location line. Let's talk about what that is. That is the line, when you draw a single 2D line, how does the wall sort of grow out of that 2D line? And by default, what it was set to is wall center line. So the wall would always be centered. So if I go down and choose these walls now, for example, this wall down here, you'll see it still has a location line of wall center line. Okay, so what happens, I'm going to put a little reference line down now that'll help me sort of figure out where that is. I'm going to say, let me draw something called a reference plane right at the center line, just so you can sort of see where that is. Let's go through and change to a different wall type. If I change to another wall type, for example, a 4-inch wall as opposed to an 8-inch wall, notice what happens. Okay. Since the wall is based on the center line, it stays centered even as it gets the new thickness. If I change to a very fat type, okay, it again stays centered. If I go to a very fat type, it'll again stay centered. So if the wall center line is kind of the basis for how it's done, if you change the type of the wall, it'll always sort of resize itself based on that center line. Now, typically not the way you want to do this, because what ends up happening is as you're going through and doing your drawing and you go ahead and make things a little more detailed, you probably don't want it to go both to the inside and the outside. A much more common condition is that you actually sort of either want to sort of hold the outside face and push in, or hold the face of whatever the structural layer is, and then push in from there. So let's talk about that in terms of some of the different options. Walls have these kind of options to them, and so there's all these different lines that are sort of interesting lines on a wall. I'm looking, oh, it's up in there. It's just hidden from me right now. Walls understand all these different locations. Wall center line, core center line, finish face, interior, exterior, core face. Let's talk about what all these are. In a lot of walls, you have some sort of central core of the wall, the main structural layer. And then on the inside and on the outside of that core, we'll have some sort of different materials. We may have some gypsum wall board or something like that that's on the inside. On the outside, we may have some nice plywood sheathing or some sort of layer out here, which gives it a little like some substrate. Okay, and beyond that, we might even have an airspace and kind of some exterior finish layer that's out here, whatever it is that we have going on out here. So as we go thinking about the different locations of the wall, here's what you have the choice of. You either have the center line of the whole wall, which is right there regardless of the thickness. You have the center line of the core, which is right there. And you can kind of decide which one you want to work with. Like I tend not to work with center lines very much. Maybe on interior walls I work with them. You have the finish face of the interior and you have the finish face of the exterior to work with. Okay. Then you also have the faces of the core. Okay, so let's think about this. As you're going through and drawing or building your models and stuff like that, there actually are some places that are better than other places in terms of working on your models. For example, if you're doing some sort of wood frame construction, and I'll apologize if it doesn't look sort of very familiar to everyone, but this is kind of the way we typically build like houses here in the Bay Area. We have something going on like this where we have a stud wall, some top and bottom plates. What'll happen inside of that or on the outside, even out here, I'm going to finish this up nicely. We'll have some floor and some sort of rim joist that's kind of happening in there. I can draw that straight. What will happen is on the outside, we'll often have the plywood kind of lapping down all the way over all those things. And we'll also have the finish layer, whether it's siding or whatever it is that's coming out here. Shingles, whatever it is up there. Okay. We'll have some sort of sheetrock in here. It's kind of a very typical kind of wall assembly for around here. So, as you guys start thinking about how to place your walls, of all the different areas that you could, there's the whole notion of center line, very rarely used to place things. You could say that you're measuring the outside face of the wall. That's often, on an existing building that you're trying to retrofit, often we'll measure to that because that's all we have to go with. But if you're designing new things, really one of the most interesting places to go through and measure to is really the face of the core. And the reason is, if you really think about how something is built, and it's built in a specific order where typically the core is placed first, and then everything that happens either on the exterior of the core or the interior of the core just happens as layers that are added to the core. But really, the core is really the thing that drives the placement of everything. So if you have a concrete block wall that has some sort of stucco finish on the outside, it's really the face of the concrete block, not the face of the stucco. Because the face of the stucco will vary a little bit. It's always the core that sort of drives. Same thing with wood frame walls. So, what's this all about? Really, it's really when you start thinking about how to place walls in all those different places, the one that I think you're probably going to get the most value out of is actually the core faces, as opposed to the exterior or the exterior faces. But again, it really depends what it is you're trying to model and what you have to work with. If you're tracing a lot of DWG files that someone has given you, and they only have kind of single thickness walls with lines for the inside and the outside, you're probably going to be pacing based on the finished face of the interior or the exterior, something like that. But if you're building it up from scratch, you're probably going to be based on the core. But go ahead and choose which one you want, because watch this. Okay, if, for example, I take that wall and I say, let's go ahead and change it to the center line to be finished face, or the location line to be finished face exterior. I'll just go ahead and put that line at the exterior face just to kind of give myself a point of reference so I can see where that's going. Since that is now finished face exterior, if I change things, the exterior is going to be honored. So think about really what is the line that you want to honor regardless of how the wall thickness changes. And that's really the one that should be your wall location line. Okay. Or if you place a bunch of walls and you know the outsides are where they want to be, but they're currently set the wall center line before you change the thickness, change the wall center line, location line to the exterior face, because that will be the one that's held constant when you change the thickness. So that's really your anchor point. Okay, long-winded explanation to kind of get you through that, but the location line tends to be important. Okay. Second thing you want to start paying attention to with your walls is just the tops and bottoms, these top constraints and the base constraints. For any wall, you can see that, for example, can I pull that up there? This wall is currently going from level 1 to level 2. If I choose the wall, you'll see that it's going from level 1 up to level 2. Okay. The nice thing about going from level 1 to level 2 is if level 2 changes, we say that as opposed to that being only 10 feet up or whatever it is, now level 2 is going to be 15 feet up. Okay, the nice thing is back in our 3D view, okay, it's also 15 feet now. Whatever we go through, if you say it's to level 2, when level 2 changes, the height of the wall will change before it goes relative to feet. Okay, there's a couple of other little variations. Yes?
I just want to say, so for all the walls, it's like, I made it a lot thinner.
Yes.
And did it with respect to like the interior.
Yes.
If the wall is attached to it, it doesn't move, so it gets cut off. But it doesn't have to be. So you just kind of go and just take this thing.
Let's take a look. I was good on the mental image for about half of it, and then I got lost. So let's see what you got.
So you just have this will be used to do.
Yeah. So yeah, that's interesting. I'm actually sort of curious. I was just it's funny. It doesn't actually think those two are joined. It's it's kind of an interesting one. We can rejoin them, but pulling it out and giving it. Yeah, it's interesting that if the wall thickness changes such that it leaves a gap, that it actually left a gap. I'm sort of surprised, but I'll accept it. I just don't think they were doing that. You're right. I would have wanted to do the other thing with this sort of joint important too. Yeah, it's a very interesting little hole. Anyhow, we'll figure that out. Okay, relative to this wall, let's think about, you can just say level 1 to level 2. A couple other variations I want you to know about though. If you choose that wall, we can go ahead and either put an offset at the top of the wall or the bottom of the wall. Let's think about how that might be useful. For example, if you know that this wall is going to go down to level 1, but you also know that it wants to go 1 foot further than level 1, wherever that is, what you can do is put a base offset in there, and we can say, oh, minus 1 foot, and that wall will stick down. So what's going to happen? It's going to continue to follow level 1, but with a 1-foot extension going deeper below. Now, that isn't necessarily so useful. Sometimes I do that around the outsides of buildings. When I have level 1 here, and I actually want this siding to continue down and cover the subfloor, I'll sometimes put a negative offset at the bottom just to get the siding to wrap down further. Okay, and that's kind of a cheap and easy way to do something like that. Another variation you might want to work with is, if you're working on sort of a covered porch or some sort of exterior balcony or something like that, you may want to have something where we have a soffit wall coming down where there's an opening that's, say, 8 feet or 6'8" high off the floor. And how you can do something like that is, if I want to have that wall start not right at level 0, but say 6'8" above level 0, okay, you'll basically get like a little soffit wall around the edge of a covered porch, or again, yeah, just some sort of balcony or something like that. So, negative offsets or positive offsets. You can change the offset at the bottom, you can change the offset at the top. For example, a good top offset might be, let's say you have the wall, it wants to go to level 2, but you actually want a little 3-foot or 4-foot parapet wall at the top. Or some sort of little balcony wall around the outside edge, just maybe have some roof garden or something like that. What I can do is say, great, here I am, I'm hanging around, I'm going up to level 2. But if I want it to have a little bit more, I can put a top offset, either a positive one if I want it to grow up, or a negative one. And why do I sort of care about doing it with these offsets? Because if level 2 or level 1 move, the offsets will always be honored. So that opening is always going to be 6'8" tall, regardless of wherever level 2 moves to. Or this is always going to be 4 feet above wherever level 2 got to be assigned to. I say, it's a little bit stronger to do that. So this top and bottom offset's definitely kind of cool stuff to play around with. When you are trying to model things and having some difficulty, we'll often find that that's the key to making it work right, is to really be very careful about how to define it. Yeah?
I'm having trouble where the wall thinks that it's basically the exteriors on the interiors. Is it easy to put that around?
There certainly is.
Right.
Let's talk about that. Okay, so let me zoom on out here. If you've got your interiors on your exterior, or vice versa, here's what you got to do. Over here, when you click on a wall, see it's got this little glyph on this little widget, this little arrow. If you click on that guy, it'll flip the inside and the outside around. So again, like that. Or let me show you in 3D, we can do it there too. If you got this wall here and it's flipped inside out, if you right click on it, there it is, change walls orientation. It'll flip it inside out. And it's a real easy thing to kind of have happen to you. Let me kind of tell you how it happens, just so you sort of get a sense of that. As you're drawing, you actually, even if you don't think about it, you're actually determining the directionality of the wall. Let me show you what I mean. Let me go through and do this basic wall that has all the layers so you can sort of see it. Watch this. If you draw, no, not that. I wanted to go for that nice wall that has all the layers so you can see the inside and the outside. If you draw in what I'll call a clockwise direction, okay, the outside stays on the outside. Okay. If you draw, it's going to sound very weird if you don't think about this as being clockwise or counterclockwise. If you draw in a counterclockwise direction, okay, your insides become your outsides, or your outsides are on the inside instead. So the key to that is, if you can remember when you're placing walls to place them in a clockwise direction, that is clockwise relative to the center of the drawing. Okay, that'll help. But if you get yourself in trouble, not to worry, you could always just go flip individual walls around, or flip them all around. It's a real quick thing to do to kind of flip them around. Okay, so one thing that happens there in terms of those. The next thing that people typically run into with walls is, you say, hey, these walls are kind of okay, but you know, for what I'm building, my walls don't look like this. Okay, I want something else a little bit different, so you can customize these things. And what we're going to do is, for the purpose of the little practice thing I'm going to give you to work on, actually we have some wall types already defined for you that are very common wall types for residential construction in Northern California. Some wood frame walls that have some stucco or some siding or some shingles on the outside. Some common ways we do it residentially around here. But we can adapt and adjust these things whenever we need to go ahead and make our own wall type. So let me just kind of show you how that works so you know where it came from. Here's basically the deal with the walls. As you're going through and working with walls, you get this nice list of all these different wall types. But again, if that doesn't look like the type of walls you want, here's what I want you to do. Go through that list and really find it's the one that's probably the closest to what you want, but not quite right. Okay, so stud wall, stucco, I don't know. Let me go for brick on metal studs. Maybe that's close. It's not real close, but it's a start. Okay, and let's take a look at how that wall is defined. Now, that wall by itself right now, we could use it, but if I want to edit the wall and create our own wall type, here's what we're going to do. We're going to repeat these words again and again, because whenever we have things that aren't what I want, what I'm always going to do is edit it and duplicate it and change its parameters. So we do a lot of using existing types and duplicating them and then changing them to be what we want them to be. So I'll say edit it. This is kind of the current definition for that brick on metal stud, not what we have in mind. So I'm going to say duplicate. If I change this one, it'll actually change the brick on metal stud. I'm going to duplicate it so I can create my new one. And I'm going to say, oh, it's going to be 2x6 studs plus a stucco exterior. Okay, so far all I've done is I just changed the name. I just created a new wall with a new name. I haven't actually changed its structure. Now when I change the structure, what I do is I click on this button right here under structure where it says edit. And when you edit that, you'll actually open up the wall assembly. So let's take a look at this. There's all these different layers that are assigned in here. And out of all these layers, we sort of compute not only what the thickness of the wall is, we also have a thermal resistance, a thermal mass, a lot of characteristics of the wall that are determined by all these layers. And the nice thing is if you go through and you use all these layers appropriately, you get good estimating quantities. You get good like thermal analyses. Like if you define your walls nicely, really the engineering behind it all will work out well. So let's think about our wall and how it's going to be a little bit different. Here's the core layers right here. So in the middle of the core is some sort of structure. It's currently metal studs, 6 inches wide. Okay, if I'm going to go ahead and on my wall, I'll have 2x6 studs. I'm going to have a 1/2 inch of gypboard on the inside. I'm going to have a 1/2 inch or could be 5/8 an inch of plywood sheathing. Okay. And then something on the outside, whether it's stucco or siding or whatever I'm going to put out there. I'll put something on the outside, maybe about 1 inch of that. Let's think about how we define a wall to do that. Okay. Starts with the structure layer right here. Metal studs, 6 inches, not what we have in mind. 2x6s. How wide are 2x6s? Very good. For people who aren't familiar with nominal dimensions versus actual dimensions, I apologize for this. You're going to get used to the idea that 2x4s are 3.5, 2x8s are 7.25, 7.5. 2x10s are definitely 9.25. It drops off in weird ways. And then I defy someone to explain how the logic behind it. But okay, we have metal studs right now, 5.5. Well, 5.5, that's pretty good. Metal studs, though, not sounding right. Let's see what I can come up with here. There's a material call out here, and if I go to materials, by clicking on that little button right there, it'll open up a little material dialog. And let's take a look at what we have available here. Now, this little place where I'm about to go now in terms of the materials dialog, this is one of the places that looks different between 2012 and 2013. So let me kind of like show the 2013 vision. The 2012 version is not all that dissimilar, but it's a little bit different. Okay, if I want to go through and say that that middle layer is actually, when you think about what it is, whether it's really a combination of wood, dimensional lumber, and fiberglass insulation. It's kind of some combination in there with some ratio. for right now, I'll just say, oh, let me fill it with wood dimensional lumber. I should be better about this in the long run. But let me pop on down here and see if I have, well, I have plywood sheathing. See what I have in there. Don't have like wood dimensional lumber there. Let me take a look, softwood lumber. Yeah, I'll go for that. Should probably do a better choice, but I'm going to choose that. I'll say okay to that. And I've assigned that material to it. What's going to happen is you're going to find out that there's a lot of materials that are already defined, and if we don't have the material we need again, we're going to duplicate it and kind of create a new one. And we can create an appearance for it and really set all its thermal properties, whatever it is, to have model accurately. Okay. As we move out from the core layer, plywood, looks like the substrate, we're actually doing pretty good there. It's currently showing at 3/4 of an inch. I suspect that for our little structure, instead it's going to be closer to a 1/2 inch. I can enter that a lot of ways, but I'll say 0.5. So 0 feet, 1/2 inch. You might notice as I'm changing things, the thickness over here keeps on changing a little bit. Looks like it has some air barrier, that's fine. This wall also has an air layer of 3 inches. Now that I'm not going to need, so I'm going to take that out. And finally, we have out here some sort of brick layer, 3 5/8 inch thick. If I'm going to put some sort of 1 inch stucco layer, what I'll do is again change the layer thickness. And we're going to change the material. So I'll say, hey, you're not brick. Let's go out and see what we got. Now, if you don't have stucco in the list here already, and as best I could tell, I couldn't find stucco in there, what I can do is go down in the list of materials here. These are ones that I can pull out. Under plaster, you'll actually find stucco down there. So if I want to add that into my list of materials in the document, I can just double click on that. And it'll be showing up in there somewhere down at the bottom. There's stucco. Now, for all these materials we're assigning, they have a couple different things going on. They do have the issue of kind of a color, they have a pattern, they have a thermal properties. If you want to, for example, say that, hey, for the stucco, let's go ahead and shade it with a little bit of color, a little bit of pattern, so I can sort of see that in the 3D views, what you can do is as follows. If I want to take that stucco material and look at its properties a little further, I can double click it. And let's see what happens. Actually, maybe I'll try that little guy over there. There we go. You'll see that stucco has a number of different things. It has some graphic appearance things. It has some physical and thermal properties. Let me go to the graphics tab and show you what it's got there. One thing it has is this notion of really what color it should render as. And since in my little house, like most things are kind of rendering in shades of gray, I'm going to go ahead and choose a different color for this. I'm going to choose, kind of more of a brown color, just so I can spot it. You can also decide if you want to put a little bit of pattern to these. If you are familiar with working with patch patterns in AutoCAD or in a lot of different systems where you can sort of apply patterns to things, we have surface patterns and cut patterns. Surface patterns are if you're on the exterior of something and is looking at it from the outside, it's not cut through, how that should appear in a 3D view. Cut patterns are if we're actually cutting through something, how it should appear. But for a surface pattern, rather than none, I'm going to go scrolling on down the list here, and I'm going to find, like dense sand or something like that. Something just to give my stucco kind of a little stippled appearance. Maybe for my siding, I could use these nice horizontal lines, or for the shingles, we actually have a nice pattern that we could use that looks more like shakes too. And I'll say sand dense. And I'll say OK to all these things. But what I've been doing is just really defining the appearance of something called the stucco pattern. So where are we now? We have been redefining a wall. We now have a 2x6 and stucco wall that has gypsum boards and softwood, plywood, and a stucco in there. And now if we use this, hopefully it's going to have the right thickness and also have the right appearance on the inside of that side. Now, for what you're doing, you won't need to define all these. I'm going to give you a file that has a bunch of them already defined in it, but I want to let you know where they all came from so you can customize it. Yes?
problem cutting the air to zero? It's not, it says it's not a membrane, so I have to change the function.
Well, let's take a look. No, it's definitely sort of fussy about a lot of things.
So,
Only layer of the function set the membrane to have 0. Okay, so try that. So let's go ahead and in the function. Actually, for what it is in there, I just took out the air completely. I just deleted it. Yeah, that'll work. Where the air infiltration barrier is more like the membrane of 0.
okay.
That should work for you. Okay, let us do this. Let's say, okay, let's use our new wall type. Okay, let's see what this thing looks like now. So I got my new wall type. Let me come back to the 3D view. We'll apply it. So I got my new wall type. If I go through and say I want my 2x6 studs in stucco, you'll see it actually changes. It changes the thickness. It changes the appearance. It sort of is kind of changing things so it's doing approximately what we want. So again, let me leave you with the notion that changing all these layers within a wall tends to actually be one of the more confusing things we can do in terms of setting this all up. We're going to give you some wall types that are already defined, so you can just pick them up and work with them. But I want you to know that you can customize these because as you're starting to model real construction assemblies, you get to the point where you really care about that level of detail, about how all the layers are fitting together. Yes?
So right now, is it actually assuming you have 5.5 inches of solid wood? Doesn't actually
Yes.
Studs. Can you model studs?
Actually, you can. It's kind of a real mucky thing. We'll probably do it on Wednesday. Where usually what I would do is actually fill it with insulation and then model the studs as separate elements that go inside the insulation. Okay, it's a little strange. Yeah, because those weird things, rhythmic structures of alternating materials are weird or hard in this game. But we're going to hit it with rafters and joists too. So it's all the same sort of issue. Okay. So we got some sort of wall that's kind of hanging around in here. Really, working with walls tends not to be all that difficult, but let's go and kind of show you some other variations on it. You're creating these walls. We've been creating these exterior walls. There's some interior wall types available for you to work with too. So one thing to think about as you're working with all this stuff is you're going to have some sort of overall notion of the architectural design you're trying to achieve. But you always go through, choose the wall type. For right now, I'm going to use this 4 7/8 inch wall. Again, that's more of a commercial wall type. I'll give you a wall which is more a 4.5 framed wall, wooden frame wall. But you choose a type. You choose a height, like up to level 2, and then you can just basically start placing walls. So I can say, okay, I want walls through there. I'm going to break that off as a room right here. Break that here. Maybe cut that across here. This room over here is going to have some sort of closet across here. My scale's way off, so don't hate me for my scale, but it's really pretty bad right now. But go ahead and start placing like the interior walls, the exterior walls. Just sort of do something like in terms of getting the basic layout. Again, what happens is as you're working, if it turns out that after you place the walls, the dimensions aren't quite right, you want that actually to be 20 feet as opposed to 24 feet, you could always go through and move things kind of after the fact. That's 20. That should probably be only closer to 16 or 15. Maybe this thing over here, yeah, 16 feet is probably okay. But start subdividing out the space to kind of create the space that you want. Actually, this structure is ginormous right now. Maybe I should be smarter about it and shrink it up quite a bit. Okay. So once you've gone ahead and placed some basic walls, and you'll get a chance to kind of practice that some, the next thing that most people typically want to do is actually start thinking about putting doors and windows inside the walls. Now let me change these walls. They're currently sort of just the generic 2. Let me change those to the stucco 2 also. Okay, and when it comes time to playing with doors and windows, there's all sorts of things we want to be thinking about. There's views, the aesthetic qualities of like what we're able to sort of see, with the light quality on the inside, ventilation, and capture solar radiation, even things like just worrying about emergency egress, a lot of different architectural considerations that go into choosing where you want windows. But let's talk about how you place them just as a modeler, and think about how that all works. It's going to turn out doors and windows are really very, very similar operations, or work very, very similarly. Walls had a funny quality where to generate them, what you did is you drew a 2D line and the wall grew out of the 2D line. So you trace the line, the wall should be based on the height and thickness. Things like doors, windows, even things like furniture and pieces of equipment, and just really components, little objects where you buy it. Walls, you don't buy a wall at Home Depot. You buy all the pieces and assemble it and put it all together and do the wall that you want to create. Doors, you actually buy at Home Depot. You go down, you buy a door from the manufacturer. It comes out as a 3-foot door. It comes out as a 32-inch door. You specify the type of door it comes. Same thing with a lot of furniture pieces. Things that aren't custom manufactured, we often model as components. And how they work within the Revit environment is as follows. There's doors and windows right here. I want to do windows first because I think that's actually a little bit easier to think about. You choose the window tool. And as you want to start placing windows, you can do this either in 2D or you can do it in 3D. Doesn't really matter which one you want to do it. But you have this notion of there are different windows available. You'll find the default template's very boring. It only has fixed windows. So windows that don't actually move, we have some different sizes in here, but let's put some of them in. I'll put in some of these 36 by 48 windows. Choose that size. So I'm going to put them in. I'm going to put it over here. I'm going to put it over there. So I'm putting windows into my structure. Now, as you're putting windows into your structure, let's kind of show you it in floor plan view so you can sort of see what it looks like there too. As you're putting windows into your structure, a couple of things to be aware with. One is, as you're going through and putting your windows in, windows have an inside and an outside too. And what you want to do is actually, as you're placing windows, go ahead and place them so that when you drop them in there, your cursor is just ever so slightly to the outside of the window. So what I'm doing now, can you see my cursor is just barely on the outside? Okay, that's going to place them in the right direction. Windows have insides and outsides too. A fixed window, you may not notice it. But if a window goes in backwards, very much like if a door or a wall goes in backwards, we can flip it. Okay, and I can rotate it over. Okay, and flip it over. So you can go through and place windows in a floor plan view or in like a 3D view. I'm talking about one of the differences between doing it those two ways. When you place windows in a floor plan view, one of the attributes of the window that you might want to know about is they actually all have a default head height and sill height. Okay, 73. You can choose either one of those, and it'll sort of move the 4 feet between the two. Okay? But it's always going to put them accurately at that sill side and the head height. So I put these three in kind of based on, like in floor plan, I actually brought them in there. So when they came in there, they actually had a head height of 7 feet. That's at 7 feet, that's 7 feet. If I come over to this side, they may or not be, oh, they actually did pretty well in terms of coming in. When you're doing things in 3D, you have a lot less control over the height at which things go in. So for example, if I come back over here, you'll see when I was putting those in 3D, they're kind of at random heights right now. To fix that, it's really easy. What you got to do is just go through and choose them. And you can put in the values, like 7 feet, or 6'8", or think about this, on every different structure these days, there almost always is a uniform height for the heads of the windows. It often matches the same as the top of the doors. And it used to always be 6'8", but more recently we do things more at 7 feet or 8 feet, just depending on architectural effects we're trying to achieve. So there'll be some desired effect, but if you need to change the windows, you can change them after the fact just by typing in values and getting them to come up to the right level. Okay, so we can have some different levels there. Now, these windows that I'm putting in here, they're kind of okay. If I want to go through and put in another window like the 36 by 72, I can switch over and put a bigger window in there. That's kind of okay. But you might notice that, you know, these fixed windows are kind of okay, but my architectural design is a little more interesting than that. I might want to put something in here which isn't these big rectangular fixed windows. So you say, well, great, I'd love to put in some windows that have some more interesting features, but if I go to the window tool over here, I don't really have very many options. Okay, so we got to do something. And what we can do is actually load in some more windows. It's the whole idea of a library full of things. You load in whatever you want. Some of which came from the Revit library. We can load in some new types in the Revit library. We can also load in new types that came from window manufacturers. So if you go to Anderson, or you go to Pella, or you go to Colby and Colby, or whoever, we'll have libraries full of stuff that you can bring in to actually match their component line. So let's go ahead and take a look at what we have available to load in that's just in the Revit library. We can go out to the web if we need to get more. What I'm going to do is choose Load a Family. And when I choose Load a Family, what it's going to do is say, okay, you can load a family. Let's go out to your library. If your library is installed, if your library is not installed, you're probably going to have a big empty folder here right now. But that's okay, we'll fix that. We are going to scroll on down. Yes?
So I don't have a load.
Okay, let's see if we can figure that out. You'll usually get a load if the window tool selected, or even if you say Insert, you'll say Load Family. It'll be there too.
Okay, so I load family.
Let's pull on down. We'll go to the windows. Let's take a look at what's in that folder full of stuff. I got some nice archtop windows. I got some nice awning windows, some nice casement windows with some grids in them, a nice little round top window, elliptical windows, louvered windows, skylights, transom windows. Got a lot of different things in here. Not nearly as many. I'll give you another library that has a lot more of them in here than this, but let's go ahead and just put that arch top in there for now. It's kind of a nice little decorative window. I'll say open that. As soon as you bring in the arch top window, you'll see that it comes in with some of its own sizes. So I can go ahead and choose, oh, how about a 24 by 48 arch top? I'll put some of them in here. Looking pretty good. You can change one of the existing windows to the arch top. If it's in the menu over here, the type selector, you can go ahead and change it to something else. So you can start changing the windows around a little bit like that. You can also go ahead and let's bring in another type that's a real favorite around here in residential construction. Under Windows, let me go ahead and pull in the double hung window. I pulled in double hung with trim. And let me go back out to my window tool. We'll drop some of those in. Now the double hung is actually one of the few where you can see it. There really is an inside and outside the windows. There's really an interior sash and an exterior sash, and the two will pass past each other. So that's one of the few where you'll actually notice if your windows are inside out. This little double hung. Now, as you're working with your double hung windows, or any of these different windows, you say, okay, great, I got these different styles, but you know, I wanted something that was a different size. I think it's great that we have things in here like, oh, you know, 36 by 48 and 36 by 24. I really wanted to put in a window that's 48 inches wide by 60 inches tall. That has a different size that I want to put in. Okay, so not to be spared, there's always a way around this. Let's think about how we can go through and fix this. It turns out that all these different windows and all these different components are defined by a series of different parameters. And if, for example, you choose that and you say edit the type, you'll see there's a bunch of different parameters that define it. So let's think about that. If, for example, I was working on an old historical house and the exterior trim didn't want to be 3.5 inches, you want it to be something much bigger, 6 inches or 8 inches, or something that was really chunky. What I could do is just change the parameter here, 0'8", and when I say OK, the trim will apply itself and sort of be resized automatically. Actually, a lot of things that happen here. Not only will the trim resize itself, the sill fold itself out to match the trim. A lot of things happen for us that we're actually pretty smart about doing that. And that's really cool because now, as opposed to the world of drafting where I might have to fix a whole lot of things on a whole lot of sheets, if I just go through and change that, no, that was a little bit too much. Maybe really 6 inches is enough. Okay, boom. Elevations, sections, 3D views, no redrafting. It all just kind of came out of changing that one parameter value on all the windows that are using the same family type. So one really good thing about parameter values is we can go through and really quickly start changing things. So you'll find that even as we're going through and I'm putting components into a space, I'll have a big rectangular table. I don't need 15 different rectangular tables. I have a rectangular table which is 3 feet by 6 feet. I have another one that's 4 feet by 8 feet. I have another one which is like 3 feet by 3 feet and only 14 inches tall that I'm going to call a coffee table. And you just sort of mess around with parameters that you want. You'll be amazed at how we can stretch and deform different geometries to kind of create whatever we really want. So parameters are huge. The other thing that you can do that's really nice with these parameter values is I go through and choose that window. Again, 36 by 48, close, but not what I need. I can edit the type. If the type that I need isn't available in here, kind of like if the floor type or the wall type isn't here that I need, I can duplicate this and say, hey, I would really like something that's 48 inches by 60 inches. That's just a name that we're going to be using. Some of the parameters that are available for us are, for example, the width, 48, and the height, 0.60. I can say OK, and basically grow a new size window. So very common thing. We're going to do this an awful lot. Whenever there's something that's close but not quite, you're going to create yourself a new one. Okay, just about done for today. Let me finish up with just a few more things since I got off to a late start. Okay, in terms of, yes?
I just want to ask, in terms of putting windows in the second story, how can we put them so they're exactly level so that you can see them on level 2? Exactly.
What I should actually be doing is on the level 2 floor plan I can be placing them, or let me show you the other way to do that. It's what you need to do is as you choose these windows, okay, they're always based off of some level, level 1 or level 2. If I want to base them all off of like level 2 and maybe put them like 3 feet above the floor, I'll choose them all. I'll say, you guys are all going to be relative to level 2, and the sill height is going to be 3 feet off of level 2. What is that? Oh, it's because, that's actually kind of funny. This wall is actually going up to level 2. That's why we're sticking up out at the top right now. Okay. But no, that would be the way to do it. Here, let me fix that for you. For my wall, let me say it goes up to level 2, but not 4 feet off. Let me actually take that all the way up to the roof level. Okay, that'll make more sense. Yes?
I view the windows on the 3D view.
Yes.
Doesn't show level 1.
Now let's talk about that. Where that can happen is, let's say for example over here I got this window. Okay, it's 3 foot off. That's looking pretty good. Can I choose that? What happens sometimes is if the sill height of the window is actually above 4 feet, okay, because the wall, the floor plan is cut at 4 feet, the window's there, it's actually just above the cutting plane. And we can go through and do something on the view to go through and raise the cutting plane in that area so you can see it. For example, a real classic case that gets you in trouble is these guys up here. All these little like kind of clear story windows. If you look at the floor plans for this room, they never ever show up because we're always looking at the sheetrock and metal stud layer here. We don't actually see those. So what happens is sometimes when we have high windows, we actually sort of change the height of the cutting plane, or we do a second one that actually shows those clear story windows instead. So if they're there in 3D, they're there. We may just have to sort of adjust the 2D view so they'll show. Oh, no, if they're there in 3D, you see them on the 3D view, right? Okay. it's always a sort of an issue. And what happens here is, okay, see the archduct windows, they're relatively high. Choose one of those. And let's look at where the, see the sill height is at 7 feet? Lower that to say 3 feet. And then say apply. And what will happen is then it will show up. Okay. Or the other thing we're going to learn to do is we're going to, in the floor plan view, raise the cutting plane so that it intersects the 17 up. 2 ways to skin that one. Okay. Let's give you one last thing, and that is doors, and then we'll let you turn you free to play. Doors are very, very similar to windows. Doors look like this. When I go through and put a door in, you'll find that the default template has the world's most boring door, the single flush door that every 60s ranch house has. It's the big flat panel door. Although nowadays we put nice woods on them and we actually think them as being very groovy architecturally. But a single flush door is kind of the standard one that's in here. You can choose that door, choose a size, start dropping them in. I keep on putting doors in the middle of where walls intersect, which is not a very good thing to do. I can place them in the floor plan or in the 3D view. I can place them in the floor plan view. If you place them in the floor plan view, you can always go through and adjust which direction they swing to. For example, I'll have that be an in swing and pull it over here or change the hinging orientation. Whatever it is, they're really easy to operate with. Okay, doors have that same sort of quality though. If you want to go through and create a door that is not one of the plain single panel doors, you want to get some other ones, what you'll do is again, go to your library. You'll say load a family. How about, oh, we're gonna go to the door section of the library and let's see what we got available here. We got bifolds, we got curtain panel ones. We'll talk about that relative to curtain walls tomorrow. We have some plain openings. We have some double glass doors. We have some double glass doors that have a lot of divided lights in them. Some panel doors that have different sort of panel patterns. Some overhead doors, some overhead sectional doors, kind of like a garage door. Side lights, single glass, kind of like the door that we have here in the building. You have a lot of different choices here in terms of all these different doors. How about for what we're doing here, I'm going to go out and just grab the double glass one. Since, a lot of what we do is we put these kind of double French doors in. We'll say okay to that. I'll put it in the exterior wall. And again, for this one, we have the choice, is it going to be an in-swinger or an out-swinger? So we'll make it in-swing. Again, we could also do that in 3D. We'll put some of those doors in there too. So I am going to leave it to you guys to play with doors a little bit in terms of creating a basic structure. Okay, so I just want to give you a real brief preview of where we're going tomorrow. Let me say this, and I'm going to make that up to level 2 just so I can finish this off. Okay, a couple things that I want to sort of leave you with today. Put 0 in there. It's going to say that you have some windows that are hanging out. Okay. Where we're going to go tomorrow with all this is we've been creating this basic shell in terms of the walls, the doors, and the windows. We're going to put roofs and floors on things. You're going to find out that's pretty easy. Let me real quickly just show you where that's going, just to give you a taste of where that is if you want to start working ahead. Roofs work like this. We draw them often by footprint, where we choose what level they'll be on. And roofs work sort of like walls in that we sketch a boundary. I'm going to put a little overhang on this roof. And basically just sort of choose the walls. So what I'm doing is just choosing all the different wall surfaces. Okay, and then when I say finish that, okay, it'll put a roof on top. So that's really what roofs is all about. Roofs are sort of interesting, and roofs tend to be sort of very complex structures because of all the different surfaces and all the angular resolution that has to happen there. The nice thing is Revit will take care of all that. So whether you change the slope of the roof, okay, or even change the type of the roof, we can go through and kind of have it compute things very automatically. A really nice thing about roofs that really is an example of parametric kind of like niceness of the way this works is, for example, right now we have our house defined as a roof line. It's based on these wall locations right here. if you go back and we start making changes to the house, for example, as opposed to this just sort of being my living room over here, I really want this to be, I keep on hitting the wood, there we go, keeping windows. I stretch this on out, and this is more like my bowling alley. Okay, no worries. When I come back to 3D, okay, the roof is gone ahead and adjusted itself too. So the nice thing about these sorts of parametric structures is if I go through and I raise the floor levels, if I start moving the walls around, whatever it is, if I define it right, and the building elements will go ahead and stretch and reform themselves so that it still stays as a cohesive structure without having to maintain a lot of that. We'll play around with that some tomorrow. Okay. Let me just tell you what you can work on tonight to practice with if you are looking for something to practice with. I put out an assignment. I'll go ahead and send this out again in the email, but let me kind of show you what it is. Oh, see, is this word still open? Not open yet. Hang on. There is out there on the L drive, and you can copy it from the L drive now if you want to, or you can also go ahead and I'll email it to you a little bit later. There's a starting point for assignment 1 in here, as well as a little Word document. Let me tell you what's out there. In the starting point, there is really just a Revit file which has a lot of wall types that are very common to Northern California residential construction. Wood frame walls that have stucco, have shingles, have sidings, and things like that. A lot of the common elements, things, window types, door types that you might use, you can have a simple little cottage or a simple little house-like construction available out there. Yeah. In the program or the assignment description, you see what's going on out there. It looks like it's trying. Let's see what's happening. Come on, do your thing. Don't fail me now. Looks like it's going to fail me now. There we go. Let's talk about really where we're going to go. Okay, relative to where we are right now, I'm just going to say that the assignment is due TBD. We'll sort of figure this out. Yeah, chances are I'll go ahead and we'll get far enough tomorrow to go ahead and complete this. But in terms of what's going on for now, if you want to get started with going ahead and just thinking about the design for what we have in mind here, placing walls, doors, windows, and kind of basic layout, that'd be great. Go ahead and practice so that you do one layout during the summer. What we're going to do is as follows. You're supposed to be creating a little wooden frame structure that's going to illustrate how you can use all these different tools. The design context is we're trying to go ahead and create a little field research station. If you haven't been there yet, you'll at some point go visit a place called Jasper Ridge, which is very close to here, a little environmental research area, where what we're thinking about doing is going ahead and building some sort of little field research station where 3 or 4 students can work and not have to be coming in all the time. They can actually be out there in the field with some desks, with a little bit of a lab bench or a bathroom, just some things to kind of let them keep on working out there. You want to build a relatively small little structure, something that's only about 500 square feet. So think about that, 500 square feet, that's kind of, that's 10 by 50, that's 20 by 25, it's somewhere in there. This is not a 4-bedroom house. This is like it's a little bit bigger than a shack, okay, but it's not very big. So as you're designing this, kind of coming up with a really efficient layout is a really good thing to do. You want to have a lot of space to spare. You want to create some workspaces for the researchers, and they want little desks and chairs. They don't need the executive roll-top desk for the credenza. They kind of need a little table and a chair to sit at with a little laptop computer. Very modest in terms of what's going on, about 40 to 50 square feet for each desk to do that right. They want to have some lab bench. The picture, like an 8-foot-long bench, 3 feet tall, has a little sink in it. Someplace where you can put some instrumentation. Just have some things set up to work on. It's not really a very elaborate thing, but it's just sort of space going like that. Set the lab equipment. A little meeting area. So by that I mean, again, not a conference room. There's no boardroom that's coming in here and people are having that big board of directors meeting. I mean more it's kind of the corner of the room where you put the little round table and 3 chairs and there's a whiteboard so you can have a chalk talk. It's that kind of thing. Because you don't have much space. A little storage room at 8 by 10, something like that. An ADA compliant bathroom. Okay. If you aren't sure what an ADA compliant bathroom looks like, a handicap compliant bathroom, check out the bathrooms between here and Koopa. Okay, down in that little hallway going straight between here and the coffee place. Okay, those are really good examples of ADA compliant bathrooms. The ADA compliant bathroom is around 5 feet by 8 feet. Because what really drives the dimensions is you have to have a 5-foot radius, a 5-foot diameter, like circle, that someone can kind of navigate around in a wheelchair. Okay, so the way those bathrooms laid out is actually very good in terms of you come on in, there's a sink that doesn't have a base underneath it, and there's a toilet over here, and there's enough room that I can kind of wheel around and maneuver. Okay, so you're a real good example. You need something like that. You can't be 3 feet wide or no one could actually get through it. Okay. Operable windows, you want to have some windows to capture light and heat. They should be operable so that people aren't frying during the summertime. They need to be able to ventilate it. We're not going to have a lot of air conditioning out here. We really want this to be environmentally sensitive, just be able to open the windows and use the natural forces as much as possible. As far as the building methodology, this should be something that we can build relatively simply just by hand. But we put the students to go out there and sort of build it. So we're thinking like a simple concrete slab. The walls could be some sort of light frame wood construction. Put a little bit of insulation in there. The roof will probably be 2x8 or 2x10 rafters. You won't have huge spans. The building's just not big enough. They're going to need gigantic spans with a lot of steel in here or something like that. It's going to be a pretty simple framing job. Okay, all the doors should be 32 inches wide. Okay, no hallway should be less than 36 inches wide. Okay. To get started, again, there's an RVT file that we'll be sending you, or it's also on the yellow drive right now, that has a lot of kind of the basic pieces that you might want to work with there. And then what you're going to be doing with it is putting in walls, doors, windows. You're going to just try to illustrate your design, convey your design intent using the tool. We've done walls, doors, and windows. We'll talk about floors and roofs tomorrow, and how we put in things like plumbing, fixtures, and furniture. And then finally, we're going to take all these views of the drawing and put it on sheets that then you can then share with us and either plot out as a PDF, something like that. And just to let you know where that's going, and I really will let you go then, I'll go to Sheets. You'll see there's no sheets right now. I think there's already one set up in the drawing or in the file I'm going to give you. Let me show you how this works. We're going to create a new sheet. Again, we'll do this tomorrow. When it comes time to take this 3D model you've been working on and you want to put it on the sheets, here's what you got to do. Okay, watch my hands like nothing ever leaves. We go over here, we pull down and drop it in there. Oh, come on, don't do it. There we go. Ha-ha. We can go through and, in the same sense, take that 3D view. Again, pull it on out. Drop it on in. Okay, oh, the elevation view, you want to get that too? No problem. We pull it out. Drop it on in. Now, in terms of what we're going to do, you might recognize it'd be good if we did a little cropping, a little kind of orienting it, kind of cleaning up a little bit before doing that. But dropping them onto the sheets is the least of your worries. You're going to see it on. That part's actually going to go really, really easily. So it's all going to be doing some nice job with your design, kind of getting the views cleaned up, putting it together on a sheet, and turning it on. Okay, so between now and tomorrow, this is really about halfway through where we would like to be. That's okay. Actually making good progress. Go ahead and if you can practice tonight, get your software installed. If you don't have it installed, get that installed. We'll send out links to libraries. Make sure we get that installed for you. And if you want to start, just start playing around with, if I had 500 square feet to work with, what could I possibly do? Sketch it, work in the tool, whatever it is, but think about how you're going to be using that space and see if you can get the basic kind of layout down with the walls. See if you can get that and the basic doors and windows in there. Tomorrow when we get back together, we'll go ahead and put the floor and put the roof on. Okay? Enough to get started? Excellent. Okay. Why don't you guys get on out of here? I'm sorry for running over. We got started late the second time, but tomorrow, for you guys coming on in, you will be on a slightly different schedule because we're going to start differently. So this morning you guys came in, oh, I forget what, like at 12:30 or something like that? Tomorrow, if you guys can come in at 10:30 to noon for the morning session, and then for the afternoon session, say 2:30 to 4, that'd be fantastic. Okay, and if you're thinking about, or if you have a need to go through and switch between different sessions, you guys are actually, there's less of you here than there is in the A section. Okay, so if you can stay with B, that's super because it's a little bit less crowded and less people crawling all over each other and stuff like that. So if you can stay in B, that's fine. But if you have something special going on, like some sort of special test or whatever that you have to get accomplished, yeah, feel free to change. That's okay. We seem to be pretty much in balance between the different sessions, so we're in good shape. Great. Okay, so I'm emailing you the files. I'm emailing some people the library stuff. If you don't think you're on the roster, come up and check with me. We'll make sure you're on the roster so you get credit for all this. And other than that, go have fun to see you.